Grade D clean room. Clean area for carrying out less critical stages in manufacture of aseptically prepared products, e.g. handling of components after washing. Grade C clean room. Clean area for carrying out less critical stages in manufacture of aseptically prepared products, e.g. preparation of solutions to be filtered. Grade B. For aseptic preparation and filling. Background environment for Grade A zone. E.g., clean room in which laminar flow workstation is housed. Grade A. Local zone for high-risk operations, e.g. product filling, stopper bowls, open vials, handling sterile materials, aseptic connections, transfer of partially stoppered containers to be lyophilized. Conditions usually provided by laminar airflow workstation. Types of clean rooms, as per supplied airflow pattern. 1. Conventional. Airflow pattern is turbulent, where air circulated at optimum rate in room. Room environment cleansed by dilution principle. Clean rooms having cleanliness class ISO 6 and beyond falls under this category. 2. Unidirectional flow, laminar airflow. Airflow pattern, unidirectional, where air circulated at high velocity in room. Room environment cleansed by displacement principle. LAF cabinets having cleanliness class ISO 5 falls under this category. 3. Mixed flow. Isolator or mini environment do not principally depend on airflow for isolation but uses walls of SS and fiberglass. In the pharmaceutical manufacturing area, this technology is generally known as isolator or barrier technology, whereas in the semiconductor industry it is generally known as mini environments. SS laminar flow glovebox or isolator, LFGI, falls under this category. LFGI provides a contained environment that allows for greater protection for both personnel and product than traditional open-front laminar flow equipment, thus is used for hazardous work with toxic chemicals or dangerous bacteria. Although viable microbes cause the greatest concern in pharmaceutical clean room, control over non-viable particle contaminants is required for following reasons. 1. The airborne particulate contaminants are stopped or reduced by installation of HEPA filters. The MPPS, the most penetrating particle size, of HEPA filter is 0.3 micron, with increasing efficiency of capture for smaller and larger particles. 2. GMP accepts roughly proportional relationship between viable and non-viable, as control over non-viable shall also bring control over viable. 3. William White, during his studies, found that a viable contaminant existed between 10 and 15 micron, and no smaller, due to desiccating nature of the dry clean room environment. For the USP Chapter 1116, Microbial Evaluation of Clean Rooms states that while airborne microbes are not free-floating or single cells, they frequently associate with particles of 10 to 20 micrometer. So by controlling the large particles, more than 5 micrometer, clean room sterility or risk of losing sterility can be monitored. 5. Because dust is a bacteria carrier, dust must be controlled. Controlling the general particulate burden offers control over the viable contamination risk. It does not alleviate the requirement for monitoring for the viable fraction using other technologies like dynamic air sampler, settle plates, contact plates, etc.